Question 7b says, given the point P with coordinate 3, 5 and Q coordinate -5, 7 on the Cartesian plane such that R with coordinates x and y is the midpoint of PQ. Find the equation of the line that passes through R and the perpendicular to the line PQ. So let's go back and really understand the question. Given points P as 3 and 5, meaning the first is x, the second is y, and Q, which is -5 is x and 7 is y, on a plane such that R with the coordinates x and y is the midpoint of PQ. So let's say this is line. We're not doing it on the real graph, but just for illustration. Let's say this is line PQ, and they said R is the midpoint, this is the middle, and the coordinate of R is not given. We have it as x and y is the midpoint of P and Q. Find the equation of the line that passes through R. So the line passes through R and it is perpendicular to line PQ. When they use the word perpendicular, that means it is at right angle to PQ. So we'll draw a line that is at right angle to PQ. It's easy for us to get the coordinate of R since it says R is the midpoint of PQ. There's a formula for finding midpoint of 2 points on a graph, which says midpoint is equal to x2 plus x1 over 2 and y2 plus y1 over 2 to find both the x and y coordinates. So start with our x2 and x1. Our x2, which is for Q, is -5. Our x1, which is for P, is 3. So we have -5 for the x coordinate. We have -5 plus 3 over 2 for the x coordinate. And for our y coordinate, our y2 is 7 and our y1 is 5, 7 plus 5 over 2. Having done this, then we can now start solving. We will then say for the x, we have -5 plus 3. That's you're owing 5, you have 3. By the time you are paying back, since what you owe is more than what you have, you still be owing. Therefore, you'll be owing 2. Since you're owing 2, it will be -2 over 2. Then for our y, we have 7 plus 5, that's 12 over 2. Our answer will be, for x, we'll have -2 divided by 2. As the 2 cancels 2, we'll be having -1. Then for our y coordinate of the midpoint R, we have 12 divided by 2, which is 6. So for point R, our coordinates are -1 and 6. The x will come first, so we have that done. And back to the question, it says find the equation of a line which passes through R and perpendicular to line PQ. If the line passes through R, it gives us that R is a coordinate on that new line, the perpendicular line we are finding in the equation. And when they say the word perpendicular, the perpendicular in this sentence means the gradient of the new line, which is this, can be deduced from the old one, which is PQ. And we'll see there's a formula that says how to do it. And the formula says m to the new gradient will be equal to -1 over the gradient of the initial line, m1. And with our P and Q coordinate of the P and Q line, we'll find the gradient. And once we find the gradient, since we know the new line is perpendicular to line PQ, the gradient of line PQ helps us find the gradient of the line. Then we use our R to create the equation. We have gradient m1 of line PQ as y2 minus y1 over s2 minus s1. And with the Q behind, we have our y2 here, y1 here, s1 here, and s2 here. So our y2 is 7, our y1 is up here 5, over our s2 is -5, our s1 is 3, so -3. We have it like this. We have 7 minus 5, it gives us 2, and -5 minus 3 gives us -8. We can break that to the lowest term as having 2 here 1, 2 in -8 is -4. So our gradient for line PQ is 1 over -4. And we know from what we discussed earlier, our gradient for the new line that crosses R, which is perpendicular to PQ, is going to be minus 1 over the gradient of PQ. And to find this, we have M2 is equal to minus 1 over the gradient of PQ, as we have calculated, is minus 1 over 4. So we have it minus 1 over 4. We can then say minus 1 divided by minus 1 over 4, which is minus 1 times, when you turn the dividing sign into multiplication, it switches the values of the fraction at the back. So we have 4 over 1 with the minus. Then you have minus times minus gives us plus, and 1 times 4 gives us 4. Then we have our over 1, which is still 4 plus 4, 4. For us to find the equation for the new line as stated in the question, given the coordinate of PQ and given the relationship between PQ and R and the relationship between the line and R, for us to find the equation of a line, we need at least a point on the line with the two coordinates and also the gradient. And using the formula y minus y1 over s minus s1 equals m. So we all know that R is a point on both PQ and the new line. With this information, we can then solve. We have our y as unknown. We have our y minus, we're using the coordinate of R. Our y1 is 6. And we have our x minus, our x1 is minus 1. We have to be careful here because of the sign. We have our gradient of the new line to be 4. Since it is at right angle to the line PQ, then we can now solve this algebra. We have it y minus 6 divided by, we have x, we have minus times minus, because we have two negative signs, we have to resolve it into 1. So since we have two negative signs, and we know negative times negative gives us positive, so here to be positive 1 equals 4. When we can make it 4 over 1, we cross multiply. Then we'll have it as y minus 6 times 1 will give you y minus 6 equals, we have 4 times x plus 1. On the other side, 4 into bracket x plus 1. Y minus 6 equals 4 times x is 4x, and 4 times 1 is 4. This 4 multiplies the 2, because the 4 affects the two of them. At this point, we rearrange by making y subject of formula. Y is equal to 4x plus 4. Then the minus 6 here crosses the equal to sign and becomes plus 6. Y equals 4x plus 10. Therefore, our equation for the new line is y equals 4x plus 10. And a quick recap is the fact that we're given point P and Q and a point R, which is the midpoint between P and Q. Since R is the midpoint, we can calculate the midpoint using the formula S2 plus S1 over 2 and Y2 plus Y1 over 2 to find the coordinates of R. Once we have that, we can use the second sentence in the line that talks about the fact that a line passes through R. That means R is on that line, is a coordinate on that line, and it is perpendicular to PQ. When you hear the word perpendicular, there's something common with the gradient. There are two words you hear. It is either perpendicular or parallel. Once it's parallel, that means they share the same gradient, the same slope. But once it's perpendicular, for you to get the gradient, you can get the gradient of the perpendicular line from the real line or the original line by saying the gradient of the new line is equal to minus 1 over the gradient of the old line. And from there, we derive our gradient. Once you've gotten your gradient and you have a coordinate on the graph, you can then solve for the equation of the line using y minus y1 over s minus x1 equals the gradient for the line, and you get your answer.